So network management encompasses monitoring, configuration, maintenance of these networks. As we look to the future, we can expect trends like AI-driven network optimization, software-defined networking (SDN), and also edge computing to play an increasingly significant role in the evolution of network modeling. Now that we have a basic understanding of network modeling, let's move on to the next slide, where we will discuss the importance of standards in network modeling. So in this slide, we are going to be talking about the importance of standards in networking. So standards are essential in ensuring that device can communicate with each other and that networks can function properly. So dalam slide ini last week and this week also banyak benda yang kamu dah belajar, tapi kita akan sentuh sebab dia apa ni, dia related. So siapa dah faham dan sebagainya tu, bear in mind sebab kita nak kena faham tu sebelum kita move more deeper into the network modeling. So primary purpose of standard is to ensure compatibility, interoperability in networks. So standards cover various aspects of network modeling and communication, including the physical layer, data link layer, network layer, and transport layer. So sebenarnya kita ada 7 layer, tapi sebenarnya dalam lecture kita akan, sebab dalam network sebenarnya kita selalu sentuh 4 layer ni lah. Yang layer kat atas tu ada juga tapi tak banyak lah. Tapi especially application layer tu kita sentuh juga lah. HTTP, HTTPS tu kita sentuh juga lah. Okay. Examples of well-known networking standards include the OSI model, TCP/IP model, and Ethernet. So these models provide a framework for communication between devices and ensure that that data is transmitted reliably and efficiently. So organizations such as IEEE, IETF, and ITU play a significant role in the development of networking standards. So this organization bring together experts from industry. So kebanyakan dekat sini lah dia berjumpa lah daripada industri, daripada academia, and also government. Government untuk ni lah establish rules lah, to establish standards that benefit the entire networking community. So IEEE stands for Institute of Electrical and Electronic Engineers. So it is a professional organization dedicated to advancing technology related to electrical and electronic engineering, computing, telecommunications, and other related fields. And one more is IETF, stands for Internet Engineering Task Force. It is an open international community for network designers, operators, vendors, and researchers concerned with the evolution and smooth operation of the internet architecture. So ITU pula stands for International Telecommunication Union. It's a specialized agency of the United Nations that is responsible for the regulation and coordination of international telecommunications and radio spectrum allocation. So its mission is to connect the world, and to enable sustainable economic growth and social development through the use of information and communication technologies, which is ICTs. So benefits of standards are significant. They lead to streamline communication, increase reliability, and simplify network management. So by adhering to established standards, organization can avoid compatibility issues. So kadang-kadang kalau kita tak ikut standard, so kita tak boleh connect. So sebab benda tak sama. And reduce costs associated with network maintenance and upgrades. So the adoption of standards is often driven by industry and government. In many cases, government regulation require adhering to specific standard to ensure public safety and security. So industry associations and standards bodies also play a significant role in promoting the adoption of standards. The development of key standards has a rich history. Networking standards have been developed and refined over several decades with significant contribution from pioneers in the field. Mungkin kamu pun tak, saya pun tak pernah tengok dia mana, tapi antara nama yang famous macam Vin, Cerf, Khan and Tim Berners-Lee. So however, there are challenges associated with standardization. So balancing innovation and standardization can be difficult as macam new technologies often emerge faster than standards can be established. Kadang-kadang itulah macam rules kan, keadaan semasa tu dengan rules tu kadang-kadang tak sama kan. Dia kena, contohnya macam wifi terperlu faster dan sebagainya, tapi the standard still not move fast as we need lah. So additionally, ensuring compliance with established standards can be complex and time-consuming process. So looking to the future, artificial intelligence (AI) is likely to play a significant role in networking, bukan setakat ChatGPT, AI, everything, image and so on. AI pun main peranan dalam networking. So AI has the potential to improve network management, optimize data transmission, and enhance security. As network technology continues to evolve, it is essential that standards keep pace with this advancement to ensure continued compatibility and interoperability. So in conclusion, standards are critical in ensuring the proper functioning of networks. By providing a framework for communications and adhering to established standards, organization can enjoy streamlined communication, increase reliability, and simplified network management. So dulu dulu everyone macam Sony ke apa semua, Apple masih lagi lah, tapi macam dulu everyone buat standard masing-masing and buat device masing-masing. Tapi bila buat device masing-masing, so dia tak boleh communicate dengan device yang lain lah. Tapi Apple dulu dia tak sure lah, sekarang ni pun dia dah start dah begini. Tapi macam Apple pun dia maintain dia punya standard sendiri lah. Tapi dia boleh sebar sendiri. Tapi untuk brand yang lain semua dah ikut general standard protocol. So the future of networking is exciting. It is essential that standards continue to evolve to meet the needs of changing technological landscape. So kita akan masuk pada network topology. So penting tak network topology, kita belajar pasal different of network topology. So the importance of network topology in computer networking, and sebelum kita go tu, basically network topology refers to the physical or logical layout of a network including the devices and connection used to transmit data. Sebagai network professional, penting kita nak lihat topologi mana yang kita nak bina untuk kita punya klien, kita punya network yang kita nak bina tu lah. So there are several types of network topologies, including bus, star, ring, mesh, and hybrid. So each topology has its own advantages and disadvantages, and the choice of topology depends on the specific needs of the network. So the importance of network topologies lies in the following areas. Satu, kita nak tengok network performance. The choice of network topology can have a significant impact on the performance of the network. For example, a star topology is known for its reliability, while a bus topology can suffer from performance issues if too many devices are connected. Yang kedua, network scalability, scale nak kecil ke besar. So the topology of network can impact its ability to scale as the number of devices and users increase. A mesh topology, for example, can be easily scaled by added more nodes to the network. Number tiga, network security. So the choice of network topology can also impact network security. A ring topology, for example, is inherently secure because data can only flow in one direction. Number four, network management. So the topology of network can impact the ease of network management. Penting juga sebab kalau anything happen kan. And then a star topology, for example, is easy to manage because each device is connected directly to a central hub, while mesh topology can be more difficult to manage because of the large numbers of connection. So in conclusion, the choice of network topology is important decision in computer networking, and it can impact network performance, scalability, security, and management. So it's important to carefully consider the specific needs of the network when choosing a topology. So for this slide, we will explore the star topology, one of the many network topologies that play a vital role in network modeling. So the star topology defined as configuration where each device connects directly to a central hub or switch. The visual representation of this topology can be seen in this diagram. So there are several advantages to the star topology, such as scalability. Dia boleh besar, dia nak besarkan network, nak kecilkan network, simplicity and ease of troubleshooting. However, it also has its drawback, including a centralized point of failure and increased cabling requirement. So anything happen kat switch ni terus yang lain tu jam. So star topology is commonly used in local area networks, LAN and home network kan. Macam kita ada satu switch atau satu router. So it offers efficient performance for small to medium sized networks. So there are also variation of the star topology that can further enhance network topology. So real-world examples of star topology networks include office networks and data center, where the ease of management and scalability are highly valued. So the star topology is a type of network architecture in which each device is connected to a central hub or switch. The signals transmitted by the devices pass through the hub or switch and are then routed to their destination. So one of the main advantages of star topology is its ease of installation and centralized control. And the installation process is straightforward, as each the device only needs to be connected to the central hub or switch. The centralized control allows network administrators to easily monitor and manage the network. However, this star topology also has some disadvantages. It has a limited scalability, and the performance of the network can be affected if too many devices are connected to the central hub or switch. So star topology requires more cabling than other types of network topology, which can be expensive. And it is commonly used in a small to medium-sized networks, such as in office or homes. So basically, star topology is a reliable and efficient solution for most small to medium-sized network. However, it may not be suitable for large networks due to its limited scalability. The star topology is a type of network topology in which all devices are connected to central hub or switch. The hub or switch act as a central point of network that is responsible for transmitting data between the devices. So one of the main advantages of topology is a point-to-point connection. Each device is connected to the hub or switch through a separate point-to-point connection, which means that failure of one device does not affect the other devices on the network. It also easy to expand, and as new device can be added to the network by simply connecting them to the switch. However, star topology also have some disadvantages. The hub or switch in star topology is a single point of failure. If the hub or switch fails, so the entire network can be affected. So a star topology can be more expensive than other topologies because it requires a hub or switch to connect to a device. So let's go to the next topology, which is a mesh topology. So in this slide, we will explore another important network topology, the mesh topology. This topology is characterized by each device connecting to multiple other devices, creating a highly interconnected network. So this visual representation of the mesh topology can be seen in the included diagram. So mesh topology offers several advantages such as resilience, flexibility, improve fault tolerance. So basically dia dekat mana down ada jalan contohnya kan. Kalau dekat sini device down, so dia boleh pergi mana-mana jalan yang lain lah. Instead of satu, kalau down, network ni down. Tapi kalau mesh topology, tak kisah yang mana down, network tu still up lah. However, it also has its disadvantages such as increased complexity, higher cabling requirements, and potential higher cost. So basically kalau nak buat cabling, nak buat stand mesh ni banyak pakai duit lah. Dipanggil redundant, which is bagus untuk network tapi tak bagus untuk tak bagus sangat lah. Bagus juga dari segi maksudnya network tu tak down untuk company kan, tapi sebenarnya dia akan tengok duit lah. Kalau banyak sangat dia akan contohnya just dua ataupun satu. Kalau tak penting sangat dia make sure ada satu je line, sebab tempat yang tu down pun tak affect dia punya business. So however, it also has its disadvantages such as increased complexity, higher cabling requirement, and potential high cost. So mesh topology is commonly used in wide area networks dekat orang panggil apa uh, dekat core and wireless mesh networks due to its robustness and ability to handle large scale networks. There are two main types of mesh topologies: full mesh and partial mesh. Uh, so in a mesh topology, high throughput and low latency can be achieved through efficient routing and load balancing. Network devices such as routers, switches, and access points play a crucial role in managing connection and traffic within the network. So the mesh topology is a type of topology in which each device is connected to every device in the network. The signals transmitted by the devices can take multiple paths to reach their destination, increasing the fault tolerance of the network. So one of the main advantages of mesh topology is high fault tolerance, flexibility. The redundant network, maksudnya dia ada banyak jalan untuk lalu. Network structure ensure that network remains operational even one or more devices fail. So the flexibility of mesh topology also allows for easy expansion and modification of the network. However, mesh topology also has some disadvantages. It has a higher setup cost and requires more cabling than other types of network topology. And mesh topology can be difficult and time-consuming to install and manage. It also can suffer from bandwidth and latency issues if there are too many devices connected to the network, and it is not as cost effective as other types of network topology. So network they use mesh topology is in which all devices are connected to every other device, creating a network that looks like a web or mesh. So let's explore some key features and benefits of this network. Macam kita mention tadi is a redundancy. Every device connected, meaning there are multiple paths for data to flow. If one device fails or the connection is lost, data can still reach its destination via an alternative path. This makes this topology highly reliable and robust. So another benefit of mesh topology is its scalability. So new device can be easily added to the network without affecting its performance, making it a great choice for large scale networks. So, but it has some drawbacks. As mentioned, it can be complex in terms of cabling, as every device needs to be connected to every other device. This can lead to increased costs and maintenance requirements. Then there is another topology called bus topology. It's a type of network architecture in which all devices are connected to a single cable or backbone. The signals transmitted by the devices pass through this cable and are received by all devices connected to it. So one of the advantages of bus topology is its simplicity and cost effectiveness. So it is easy to install and maintain, and it requires less cabling than other types of network topology. Bus topology is commonly used in small networks, such as in homes, small business, or classroom. However, this topology has some disadvantages. It has potential single point of failure, same like star topology. If the central cable is damaged or fail, the entire network can go down. So bus topology is less secure than other topologies because all devices receive all signals transmitted in the network. So bus topology is the simplest type of network topology. It is easy to set up and maintain, making it a cost effective solution. So this is one of the main advantages of bus topology. The cost of installation and maintenance is lower as it requires less cabling than other network topologies such as star topology. Bus topology is also very flexible. Additional devices can be added to the network without affecting the performance of other devices. So the transmission of data is fast and efficient as it is transmitted directly between the devices without the need of intermediate devices. For the disadvantages, one of the major disadvantages is limited scalability. It is not suitable for large networks as it can become congested with too many devices. If the main cable breaks, the entire network goes down. So the bus topology is type of network architecture in which all the devices on the network are connected to a common backbone called a bus. So the bus serves as the medium for data transmission between the devices. One example of a bus topology is Ethernet, which is widely used networking technology. All the devices on an Ethernet network are connected to a common coaxial cable or twisted pair cable, which serve as the bus. Another is local talk is another example of bus topology. It's a networking protocol used by Apple computers. Also, we have example like ArcNet, Attached Resource Computer Network is a LAN protocol that was popular in 1980s. Sockering is another networking protocol developed by IBM. Use bus topology. Although bus topology is less commonly used today than other network topologies like star, mesh, and ring topologies, it is still used in certain applications, particularly in industrial settings. One advantage of bus topology is its simplicity, which makes it easy to install and manage. It requires less cabling and then other topology, which can result in cost savings. So, as mentioned, this advantages is potential for collision, lower the transmission speed, and single point of failure. Okay. So sebelum kita masuk ring topology, do you have you guys have any question regarding what we have been through the slides? If not, let's stop for 5 minutes. We will continue after 9:15. Okay, 5 minutes break. Okay, guys, let's continue. So for this slide, we will discussing about ring topology. So the ring topology is a type of network topology in which all the devices are connected in closed loop or in a ring. So let's explore some of the key features and benefits of this type of network. So in a ring topology, the devices are connected in circular loop with each devices having exactly two neighbors. So data is transmitted in one direction around the ring, typically in a clockwise direction. Each device on the network receives the data and forwards it to the next device until it reaches its destination. A token is used to control access to the network. So ring topology can be very reliable because data can still flow in the opposite direction if one device fails or the connection is broken. This ensures that the network remains functional even if there is a failure. However, ring topology also has some drawbacks. It is not very scalable as the addition of new devices can cause increased latency and slower data transmission speeds. It has a lower performance compared to other topologies like star topology because data has to pass through um, every device on the network before it reach its destination. And troubleshooting ring topology can be more difficult than other topologies as it requires identifying and fixing any issues with each devices on the network. As mentioned, ring topology is a type of network architecture in which all devices are connected. Uh, So one of the main advantages is fast data transmission as data travels in only one direction around the ring. So ring topology also scalable as it can be expanded by adding more devices to the network. So it has a potential single point of failure if the main cable or the single device fails, the entire network goes down. It's also not suitable for large networks as it can become congested with too many devices. So network that use the ring topology while ring topology is not as commonly used today as other network topology, it is still used in certain applications, particularly in backbone networks where high-speed data transfer is required. So one example of network that use ring topology is token ring LAN technology. Uh, Token ring allows devices to transmit data over ring in a logical manner using a token passing mechanism to regulate data transmission. Another network that uses ring topology is FDDI, Fiber Distributed Data Interface. It was designed for high-speed data transfer and is often used in backbone networks. So while ring topology has several advantages such as fast data transmission, it also has disadvantages such as potential single point of failure, limited scalability, and potential complexity. As with any network topology, it is important to carefully it is important to carefully consider the needs of your network before choosing the topology that is right for you. So tadi kita dah bincang several types of topology. Kita nak masuk lebih detail compared to last week berkaitan dengan OSI, tapi kita akan fokus pada first 1, 2 and 3 and 4 layer. So the OSI model is a conceptual framework that standardize the communication functions of network by dividing it into 7 layers. So this model is important because it helps network engineers and designers understand how data is transmitted and received between devices. Let's take a closer look at each layer. So the physical layer deals with physical transmission data over the network, including the electrical, mechanical, and functional aspects of the network's hardware. It includes the cables, connectors, and network interface cards that connect devices together. For the second layer, the data link layer ensures that data is reliably transmitted over a physical connection between two devices by performing error detection and correction, flow control, and data framing. So this layer is responsible for establishing and maintaining a reliable link between two devices. The network layer provides a logical address and routing services to enable data to be transmitted across multiple networks. It determines the optimal path for data transmission and ensures that packets are delivered to their intended destination. So this layer is responsible for connecting multiple networks together and enabling communication between them. And then the layer 4, the transport layer, provides end-to-end data transfer services, including error recovery and flow control. So it ensures that data is reliably transmitted between devices and can handle data fragmentation and reassembly. So this layer is responsible for ensuring that data is delivered correctly and efficiently. The session layer manages the communication between each device. This layer is responsible for ensuring that the data is transmitted in the correct sequence and that sessions are properly managed. The presentation layer translates data from application layer into a format that can be transmitted over the networks. So it handles encryption, compression, and data compression. So this layer is responsible for ensuring that data is presented in a format that can be understood by the recipient. Finally, the application layer provides network services to applications such as email, file transfer, and web browsing. So it interacts directly with the end user and provides a platform for applications to communicate with each other over the network. So this layer is responsible for providing network services to end user. So let's go a little bit detail on physical layer because some parts kita nak kena simulate dalam lab dan sebagainya. So I like to discuss, we would like to discuss the physical layer of the OSI model in more details. As I mentioned earlier, the physical layer deals with physical transmission of data over the network. It is the first layer of the OSI model, and it plays a crucial role in ensuring that data is transmitted accurately and reliably between devices. So one of the primary functions of the physical layer is data encoding. The layer takes digital bits generated by the computer and encodes them into a signal that can be transmitted over the physical medium. So there are several encoding schemes that the physical layer can use, including Manchester encoding, differential Manchester encoding, and NRZ encoding. So the encoding scheme used depends on the type of medium being used and the specific requirements of the transmission. So another important function of the physical layer is signaling. The layer determines the way in which data is transmitted over the network medium, such as radio waves, fiber optic cables, and copper wires. It defines the type of modulation and transmission method used, such as amplitude modulation, frequency modulation, or phase modulation. These modulation techniques allow the data to be transmitted uh, over the physical medium efficiently and with minimal interference. And bit synchronization is another critical function of the physical layer. The layer ensures that the sender and receiver are synchronized so that the receiver can correctly interpret the data transmitted by the sender. So this is important because any misalignment or mismatch in the synchronization can cause errors in the data transmission, leading to data loss or corruption. So physical addressing is also a function of physical layer. The layer defines the unique physical address of devices on the network, such as MAC address, which are used to identify the source and the destination of data packets. Physical addressing is essential for routing data packets correctly and ensuring that they reach their intended destination. So finally, the physical layer defines the characteristic of the transmission medium. Yang penting, including macam including is capacity, and then bandwidth, and also data rate. It also specifies the maximum distance over which data can be transmitted without degradation. These specifications are critical in ensuring the data is transmitted reliably and accurately over the network medium. So the second layer, as I mentioned earlier, the data link layer is responsible for providing error-free and reliable communication between devices over a physical connection. It takes the raw data bits from the physical layer and transform them into a logical structured format called a frame. So let's take a closer look at the function of the data link layer. One of the primary function of the data link layer is framing. The layer adds a header and trailer to the raw data bits received from the physical layer to create a frame. The header contains control information such as the source and destination address, and the trailer contains error detection codes. So this allows the receiving device to identify the frame and extract the data from it. Another critical function of data link layer is error control. So the layer performs error detection and correction to ensure that the frames are transmitted without errors. This is typically achieved using techniques such as cyclic redundancy check, CRC, or checksum. So these techniques involve adding extra bits to the frame to detect errors, and if an error is detected, the receiving device can request the sender to retransmit the frame. Flow control is also a function of data link layer. The layer regulates the flow of the data between devices to prevent data loss or buffer overflow. This can be achieved using techniques such as windowing or buffer management. These techniques allow the receiving device to control the flow of data and ensure that the sending device does not overwhelm the receiving device. Access control is another important function of the data link layer. The layer defines the rule for the accessing network medium, particularly in shared media networks like Ethernet. This is achieved using techniques such as carrier sense multiple access as CSMA uh, with uh, with collision detection. These techniques ensure that devices wait for a clear channel before transmitting data to avoid collisions, which can cause data loss or corruption. So finally, the data link layer use logical addressing such as MAC address to identify the source and destination of frames on local networks. This allows the layer to deliver the frames to the correct destination and ensure that they are received in the correct order. Now let's go to the third layer. Also, I mentioned earlier the network layer provides logical addressing and routing services to enable data to be transmitted across multiple networks. So let's take a closer look at its main function. So one of the primary functions of the network layer is logical addressing. The layer adds a logical address to the header of the frame, such as an IP address, to identify the source and the destination of the packets on a network. So this enables packets to be routed across multiple networks, and the network layer is responsible for forwarding the packets to their correct destination. Another critical function of network layer is routing. The layer determines the optimal path for data transmission between devices on different networks. So this is achieved using routing algorithms and protocols such as OSPF and BGP. These algorithms and protocols take into account factors such as network topology, link speeds, network congestion to ensure that packets are transmitted efficiently without delay. So fragmentation and reassembly are also function of network layer. The layer handles data fragmentation when the size of the packet exceeds the maximum transmission unit MTU of the network medium. It breaks the packet into smaller pieces called fragments and reassemble them at the destination. This ensures that packets can be transmitted across networks with different MTU without loss of data. So the network layer also prevents congestion of the network by regulating the flow of the data and ensuring that network is not overloaded. This is achieved using techniques such as traffic shaping and congestion avoiding. Finally, the network layer can prioritize certain types of traffic such as voice or video over other types of traffic to ensure a better quality of service. This is known as quality of service (QoS) and achieved using techniques such as traffic classification, marking, and prioritization. And for this, like the last one, let's go to the transport layer of the OSM model. So the transport layer is responsible for providing end-to-end data transfer service between devices on a network. Let's take a closer look at its main function. The transfer layer breaks the data into smaller segments that can be transmitted over the networks. It does this through segmentation and reassembly. The layer also reassemble the segment at the receiving end to reconstruct the original data. This is critical for efficient data transmission as it allows for the efficient use of network resources. The transport layer also establishes, maintains, and terminates connection between devices on a network through connection management. This includes establishing the initial connection, verifying that data is being received correctly, and releasing the connection when transmission is complete. This ensures that data is transmitted in an orderly and efficient manner. Flow control is another important function of the transport layer. The layer regulates the flow of data between devices to prevent data loss or buffer overflow. This can be achieved using techniques such as windowing or buffer management. So that one yang tadi kita bincang tadi semua yang berkaitan dengan OSI model. As model, now we go to another model. Yeah, previously and still used the TCP/IP model. Is a widely used networking model that is responsible for enabling communication between devices on the internet. It's a four-layer model that includes the application, transport, internet, and network access layers. The application layer is responsible for providing services to end users such as email, uh, file transfer, and web browsing. So it includes a range of protocols such as HTTP, FTP, and DNS. So the TCP/IP model is a simpler and more widely used in modern networking than the OSI model. It is the basis for the internet. It is used for communication between devices on the internet, including computers, smartphones, and servers. The TCP/IP model enables a reliable and efficient data transfer between devices and ensure that data is transmitted accurately and efficiently. So tadi dah berkaitan dengan model. Now kita akan masuk pula pada network protocol. So what is protocol? So a protocol is a set of rules and procedures that govern how data is transmitted, received, and processed between devices on a network. So protocols define several aspects of network communication, including data format, error detection and correction, flow control, addressing, and routing. Protocols are essential for enabling communication between devices on network because they ensure that devices can exchange data in consistent and reliable manner, regardless of the type of hardware or software used by each device. And there are many different network protocols, each designed for different purpose and used in different applications. So as we can see that, for example, network protocols are the backbone of modern communication networks, allowing devices to exchange data in a standardized and reliable manners. These protocols govern how data is transmitted, received, and processed by devices. So, for example, physical layer, protocol for fiber and wireless channel, wireless LAN, and so on. The technical layer, Ethernet, SLIP, FTP, and FDDI. Network layer, IP, IPsec, SCMP, IGMP. Uh, Apa ni, OSPF, routing protocol kan. OSPF. Okay. So transport layer, TCP, UDP, ECM, SCTP, and TCCP. So layer 1, for the layer 1 physical layer are the building blocks of network communication, responsible for transmitting raw bit data of physical media. These protocols include widely used technology like Ethernet, Wi-Fi, Bluetooth, and USB. So Ethernet is popular protocol for LANs, and it is used to transmit data packets over copper wire or fiber optic cables. Wi-Fi on the other hand, use radio wave to transmit data wirelessly over a short distance within a building or home. Bluetooth is designed for short-range communication between devices. It is commonly used for wireless headphones and other peripherals. RS-232 is a serial communication protocol used for connecting devices over a wired connection, while USB, a wired protocol used for connecting devices like computers, printers, and mobile phones. HDMI is a digital audio and video protocol used for transmitting signals between a computer and a monitor or television. So these all layer 1 protocols are essential for enabling communication between devices and networks, providing the foundation of higher layer protocols and application to function effectively. Layer 2 protocols are essential component of modern networking, enabling data transmission between devices over a LAN or WAN. So this protocol build upon the foundation provided by layer 1 protocols by providing more advanced features such as error detection, flow control, and packet framing. Ethernet is the most widely used layer 2 protocol, providing a reliable and efficient data transmission between devices online. So tokenry is a legacy layer 2 protocol that was once widely used in LANs but has since been largely replaced by Ethernet. So kita ada ATM, yang ni semua legacy protocol. ATM another layer 2 protocol that was commonly used for LANs but has been largely replaced by new technologies. Layer 3 protocols also provide error detection and correction mechanism to ensure reliable transmission of data packets. For example, the Internet Control Message, ICMP. So, layer 2 protocol, also known as a network layer protocols, operate above the data link layer in the OSI. These protocols are responsible for managing the logical addressing and routing data packets between the different networks. Some of the key layer of the three protocols includes IP, Internet protocols, ICMP, Internet Control Message Protocol, that provide issues such as packet loss or congestion as device on a network. Address Resolution Protocol ARP, a layer 3 protocol that maps IP address to a physical address such as MAC address on a network. Routing Information Protocol RIP, a layer 3 protocol that is used for routing data packets between networks based on hop count. Yang kita selalu pakai sekarang OSPF lah and BGP. RIP ni dah lama lah. So OSPF Open Shortest Path First, a layer 3 protocol that is used for routing data packets between networks based on shortest path. And Border Gateway Protocol BGP, a layer 3 protocol that is used for routing data packets between different autonomous systems on the internet. And so layer 4 protocols are essential for managing end-to-end communication between devices on network. They provide mechanism for establishing connection, managing data flow, ensuring reliable data transmission, providing reliable end-to-end communication. So layer 4 protocols enable a wide range of applications and services to function effectively over networks. For example, transmission control protocol. TCP is the most widely used layer 4 protocol that provides reliable connection-oriented data transmission between devices. So TCP use a three-way handshake to establish connection between devices, manage data flow using windowing, and provide mechanism for error detection and recovery. There's another protocol called User Datagram Protocol, UDP. On the other hand, it's a layer 4 protocol that provides unreliable connectionless data transmission between devices. So unlike TCP, UDP does not establish connection between devices, does not provide mechanism for error detection and recovery. This makes UDP a good choice for real-time applications that require low latency such as streaming media and online gaming. And Stream Control Transmission Protocol, SCTP, is a layer 4 protocol that provides reliable connection-oriented data transmission between devices. SCTP is designed for use in high-speed network data and can support multiple streams of data. We also have a control datagram congestion control protocol. It's a layer 4 protocol that provides connection-oriented data transmission with congestion control mechanism. This is designed for use in multimedia applications that require real-time data transmission. And lastly, I think for types of network, we have LAN. LAN is a network that is confined to a relatively small area, such as single building or campus. It is usually owned and operated by a single organization and used for sharing resources such as file, printers, internet connectivity between devices. And then we have wide area networks. One is a network that covers covers a large geographical area, such as country or even the world. So it connects multiple lines and other networks together using various technologies such as lease line, satellite links, and the Ethernet. So ones are typically owned and operated by the service providers. And the third one we call Metropolitan Area Network. MAN is a network that covers a metropolitan area such as a city or region. It is typically owned, operated by service provider and used for connecting lines and other network together within the same geographic area. And the last one is personal area network. A PAN is a network that is used for connecting devices within a small area, typically within a range of few meters. Examples include Bluetooth connections between devices such as smartphones and headphones, or between keyboard and a computer. PANs are typically used for personal or home use rather than business purposes. So this details about LAN, WAN, and MAN. PAN. Okay. I think let's stop here for today. Anyone have any question regarding what we have discussed in the slide? So the slide I already shared in the Google Classroom. So please check, and also later please do the lab activity. Okay, cuba tengok dekat chat kat dalam Teams ni. Quiz link. Kat bahagian chat dia. Okay, try the quiz. Later on tengok top 5 ke. Ke mana kita ada hadiah ke.